Well, I created a video and now I have to start over because apparently a video has to be here less than 10 minutes or less than, I don't know, maybe it's less than 12 minutes. Okay, so this section 6.2 may be in 3 parts. Okay, so first I want to talk about, we're going to start trig, and a couple things to note about trig and things you know from last year. One is you are probably familiar when I say SOHCAHTOA, and that is a kind of a good way to remember when you talk about right triangle trig, what the sine of an angle is, what the cosine of an angle is, and what the tangent of an angle is. The sine of an angle, so if I've got sine of theta, that equals opposite over hypotenuse. This is in terms of if I have a right triangle, which is what we'll be working with in Honors Algebra 2 next year, whether it's Advanced Precalculus or Honors Precalculus. You'll do non-right triangle trig and talk about law of cosines and law of sines. But here, excuse me, we're just working with right triangle trig. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that's where that SOHCAHTOA comes from. Just kind of a nice way to remember it. Okay, well, let's now talk about, because in order to do some of our initial right triangle trig, we're going to have to know the ratios of special triangles, which is something, again, this is something else you talked about in geometry. And there's 2 special triangles that we'll work with. One is the 45, 45, 90, so let's start there. Just, again, remembering the ratios of the sides. So say we know the legs are the same. Let's just call them 1, 1. How would we find the length of the hypotenuse? Well, and how does that relate to the legs? We could use the Pythagorean theorem. 1 squared plus 1 squared equals what we're interested in squared. And so that means that 2 equals what we're interested in squared. So the hypotenuse would be root 2. So the ratio of the sides of a 45, 45, 90 are 1, 1, root 2. Okay, so similarly, let's look at a 30, 60, 90. And in order to look at that, if you remember from last year, you probably looked at this equilateral triangle, and each angle was 60 degrees, and then you took the altitude, and because it is in this equilateral triangle, it bisects the the base here. And let's, for simplicity, say all the sides are length 2. So if all sides are length 2 and this altitude bisects this base here, then the side opposite what is now a 30-degree angle, because in this equilateral triangle, the 60 degree was bisected. So opposite the 30, I have 1, and opposite the 90 is twice that. And let's just figure out what the leg opposite the 60 is. So we have, using the Pythagorean theorem again, we've got 1 squared plus what we're trying to find squared equals 4. So x squared is 3, so our opposite the 60 would be root 3. So in other words, the ratio of 30, 60, 90 would be 1, root 3, 2. Hopefully that's somewhat familiar. I'll be honest, when I first started doing trig, and you're going to see this soon, I'd put 3 things on the top of my page. 2 would be the ratios of these 2 triangles, and soon we'll talk about what the third thing would be. So let's do an example of something, a very kind of simplistic example of something that you would know using trig. So say, again, let's just put up the ratios of the sides. So actually, that doesn't look like any triangle of the special. Let me erase that here. Okay, let's first put up, again, this is my little cheat sheet, 45, 45, 90, 1, 1, root 2, and then I've got my 30, 60, 90 triangle. God, handwriting's terrible. Which would be 1, root 3, 2. And say I asked you to evaluate the trig functions, sine, cosine, and tangent for 60 degrees, for example. So if I asked you to do sine of 60 degrees, well, you'd go to this triangle here, and you'd say, okay, from 60 degrees, since it's sine, I'm going to do opposite over hypotenuse, root 3 over 2. Cosine of 60 would be 1/2 adjacent over hypotenuse, and tangent of 60 would be root 3 over 1, or root 3, opposite over adjacent. That's just kind of a simple. Okay, so that's right triangle trig, and I feel like I'm confident you guys could do those types of problems, but there will be practice in the worksheet. Now I want to talk about something a little bit different, which I think will be new, and that is defining the trig functions if we're working in the coordinate plane. So let me draw some axes, the x and y, and I'm going to put on these axes a circle here. And let's say this circle has radius r, and I'm going to say this point in the coordinate plane, this is some x comma y coordinate. Well, and here's the angle I'm looking at. We're talking about angles in standard position. So to evaluate some trig functions here, I would take this point and I drop an altitude here. So I have this right triangle. And I would say, okay, if I want to find the sine of this angle, the sine of an angle is equal to y over r. R being the radius of this circle that was created going through this point. Cosine of the angle equals x over r, and tangent of an angle is equal to y over x. And this is the definition of the trig functions when we're talking about coordinate trig. Again, given a point in a plane, I could always drop an altitude and create a triangle, and I could have and define the trig function as the y coordinate, as the different coordinates, and it differs depending if I'm working with sine, cosine, or tangent. And it doesn't have to be in quadrant 1. You do the same thing for quadrant 2, quadrant 3, and quadrant 4. But let's talk about, well, what happens if my angle lands on one of the axes? So I'm not creating a triangle per se. I'm actually not creating a triangle. What does that mean? So, but keep in mind those definitions, because those definitions hold no matter what. So now I'm going to introduce, if we're in the coordinate plane, let's not just talk about any old circle. Let's talk about the unit circle, which has radius 1. So if we're talking about the unit circle with radius 1, let's just define some points. This would be 1, 0, 0, 1, negative 1, 0, 0, negative 1. And so say I asked you what the cosine of 0 degrees is, because this is 0. This would be 90, 180, 270, and so on. Or we could say pi over 2 for radians. Or pi for 180, 3 pi over 2, 0, 2 pi, depending if we're talking about 360 or 0 degrees. Well, say I wanted to evaluate cosine of 0. So there's certainly not a triangle formed, but I can use my definitions, and my definition of cosine is it's the x coordinate. So in this case, it's x over r. In this case, the x coordinate is 1. And because we're talking about the unit circle here, the r is always 1. So cosine of the angle, in this case, would just be 1, or that x coordinate. And all the angles that that terminate, the terminal side is on an axis, are called quadrantal angles. So you'll hear me refer to that term. And they're angles that land on an axis. So if I wanted to find, let's do something different. Let's talk about sine, if I want to do sine of 270. So we would be doing this angle here. Again, a triangle is not created, but I'm going to, using coordinate trig, I'm going to say it's equal to y over r. So in this case, -1 over 1, or just -1. So in terms of, I talked about earlier how kind of as a cheat sheet, I'd put the ratios of 45, 45, 90 and 30, 60, 90. The other thing I put on my paper when I was first learning this was this little unit circle with the coordinates of the 0, 90, 180, and 270 on there to help me if I was evaluating the trig functions at quadrantal angles.